This is 2021 Spring AMC 10A Problem 17. Trapezoid ABCD has AB is parallel to CD, BC, and BC equals to CD equals 43, and AD is perpendicular to BD. Let O be the intersection of the diagonals AC and BD, and let P be the midpoint of BD. Given that OP is 11, the length of AD can be written in the form m times square root of n, where m and n are positive integers and n is not divisible by the square of any prime. What is m plus n? Let's first draw a diagram. So notice that AB is parallel to CD, so let's draw that. Okay, so AB, you know what, yeah, something like that, whatever's. AB and also CD. And let's first draw BC. So BC equals CD, right? So if that was BC, then CD would be like this, because then these two lines are equal. And then we have like AD. So these are both 43. And AD is perpendicular to BD. So let's draw BD. So that is supposed to be a right angle. So like, let's try to make this diagram more accurate then. Okay, so we need a right angle here. So like that. And then let O be the intersection of the diagonals AC and BC. So let's draw AC as well. So that is AC. And that is O. P is the midpoint of BD. Okay, so this is P. Given that OP is 11, the length of AD can be written in form m root n. So we want the length of AD. We want AD, which is this side. Notice a right angle. We can use the Pythagorean theorem if we either find out AO and DO, or we find out AB and DB. So which one looks more achievable? I think it would be like, you could try to solve for both at the same time, because they both look quite achievable. They're not in the middle of nowhere. There's triangles that are similar, which is a really important part in this problem. So let's first look for similar triangles. Okay, so let's first connect CP, because why not? Since we know that BDC is isosceles, this is actually the median, and there's also the altitude, and it's also an angle bisector. Okay, so now that we've connected CP, we can look at the similar triangles. Notice AB is parallel to CD. So this means that we have some similar triangles over here, ABO and DOC. Right? And then yeah, so those two triangles are similar. And then we also have like POC and ADO, because these two angles are equal. There's two 90-degree angles, based on angle theorem, CP and triangles ADO is similar to triangle CPO. Let's look at some other similar triangles that we might have. So we might also have so we can also have that triangle DPC is similar to triangle ADB. Why? Because, or actually BDA. Why? Because if we do some angle tracing, so let's say like this angle here was alpha. So this means that is 90 minus alpha. And then we know that so like that's 90 minus alpha and stuff, right? So if that's 90 minus alpha, Then since AOB is similar to DOC, we know that, and also they're parallel, like AB is parallel to DC, we know that this is 90 degrees minus alpha. If that's 90 degrees minus alpha, we have a 90-degree angle right there, so that is alpha. Right? And since we know that that is also 90 degrees minus alpha because DBC is isosceles, so that is also alpha. And yeah, so like we pretty much just like know it all. We know that PDC has 90 degrees minus alpha, alpha and 90 degrees. And ABD also has alpha, 90 degrees minus alpha, and also 90 degrees. So they're similar to each other. So since triangle DPC is similar to triangle ADB, we therefore know that like we have the ratio of sides, right? So we know that the longer leg, which is clearly DP, over the other longer leg, which is clearly DB, is going to be equal to, say, PC over AD, or like DC over AB. So DP, however, is 1/2 of DB because P is the midpoint. So this means that DC, which is 43 over AB, is 1/2. So AB is 86, which is 2 times 43. So now we know that AB is 86. We also know that triangle AOB is similar to triangle DOC. So these two sides have the same ratio as the other sides in the two similar triangles. And so the other sides have a ratio of 2. So we know that PB, or 1/2 of BD plus 11 over 1/2 of BD minus 11 is just 2. So then if we solve for this, then we know that, so we multiply both sides by 1/2 times BD minus 11. Then we know that, therefore, that 1/2 times BD is 33 and BD is 66. So since BD is 66, we know that DO is 22 because that's 33 minus 11, and BP is 33, but that all doesn't really matter. We just want BD because now we have AB and BD. We can use the Pythagorean theorem inside this triangle to find out AD. So AD is going to be root 86 squared, which, let's do the math here. So we have 86 times 86. 6 times 6 is 36. 36. 6 times 8 is 48 plus 3, which is 51. 6 times 8 is 48. 8 times 8 is 64 plus 4, which is 68. So that's not 6. That's 9. That's 13. 6 plus 1 is 7. That's 7396 minus 66 squared. 66 squared. 6 times 6 is 36. 6 times 6 is 36 plus 3, 39. So we have, and the other thing is the same as 396. So 6, 15. And then 3 plus 9 is 12 plus 1 is 13. 3 plus 1 is 4. So we have 4, 3, 5, 6. So this is root 6 minus 6 is 0. 9 minus 5 is 4. 3 minus 3 is 0. 7 minus 4 is 3. So we have root 3040. So let's see. Like, how do we get 3040 though? Because that doesn't really seem right based on our answer choices given. So like, oh, actually no, it actually kind of seems right. Sorry, it's m plus n here when it's m root n. Okay, never mind. Yeah, it kind of seems right. Okay, so let's just like try to factor out all the factors from 3040. First factor you see is going to be 4. You divide this thing by 4, and you get 30 divided by 4 is 7. 4 times 7 is 28, and then 24 divided by 4 is 6, so 760. You can divide this by another 4. So you have 7 divided by 4 is 1. 6, and then you have remainder 3. 36 divided by 4 is 9, so 190. 190 is 19 times 10, which you can't simplify more. So we have 190 plus 4, which is 194 as our answer. Now that's just D. Okay.